Part 3 of Unit 5 Chemistry Paper 2026 January. Okay, first question we have here is question 10. It says this question is about compound shown. Okay, they have given us a compound. What type of reactions can this compound undergo? Right, they're asking what type of reaction this compound can undergo. We can see in this compound there's a double bond here. So when there's a double bond, we know that usually carbon-carbon double bonds can undergo electrophilic addition reactions. We learned that in this part in AS level. AS level, Unit 1, Topic 5, the last part of the Unit 1. In there we learned that if there's a carbon-carbon double bond, a bromine molecule, halogen molecule, or hydrogen halide can react with it, resulting in addition reaction. Addition reaction means you get two reactants combined together, you get only one product. So it's an addition reaction. This addition reaction is initiated by plus delta charge of the covalent molecule. So therefore we call it electrophile started it because positive species start this reaction and it's an addition reaction. So when you have a double bond, you can undergo electrophilic addition reaction. Since our molecule has a double bond, it can undergo electrophilic addition reactions. Okay, so my answer should be either A or B. Second thing is this molecule has a benzene ring. We know that benzene rings, they usually undergo electrophilic substitution reaction. So we can remember that for benzene, if you had alkyl halide, then with the presence of anhydrous AlCl3 catalyst, what will happen? This halogenoalkane react with this catalyst, gives you an electrophile. Then what will happen? This electrophile react with the benzene ring, gives you electrophilic substitution reaction. Why we call it substitution? What this electrophile going to do is replace one of the hydrogen atom in the benzene ring. So this is an electrophilic substitution reaction. Since it has a benzene ring, since it has a double bond, our molecule can undergo both electrophilic addition and electrophilic substitution reactions. So therefore answer for question number 10 is A. Let's go for next one. Question number 11. If you take question number 11, they are asking how many isomeric compound with the molecular formula C6H4Br2 contain a benzene ring. Okay, so they are talking about a molecule with C6H4Br2. So this is C6H6 benzene. So out of C6H6, we are going to remove two hydrogen and put two bromine atoms. So this is where you can place bromine atom. So if you take the structure of benzene, this is how it look like. You have 6 carbon atoms in a hexagonal shaped ring structure. And then each carbon atom is attached to hydrogen. That's why we call it C6H6. That's the structure of benzene. So what will happen when it becomes C6H6Br2? Two of these hydrogen atoms get replaced by C6H4Br2. Two of these hydrogen get replaced by bromine atoms. Now they are saying how many isomers we can have in this molecule. So one thing we can have is we can keep these two bromine atoms very close to each other. That's what they have done. So I have bromine atom here and here. They are very close to each other. Second thing I can have this arrangement is I can have bromine atom here. And then I can have a gap and you can have the bromine atom in the next carbon. So if I number them, here bromine atom is in the first and the second carbon. Here bromine atom is in the first and the, not the second, third carbon. So this is 1, 2 dibromobenzene. This is 1, 3 dibromobenzene. I can have another one. I can have the bromine atom in the first carbon. I can leave 2 carbon atoms and I can have the bromine atom in the fourth carbon. So it's like 1, 2, 3, 4. 1, 4 dibromobenzene. Now you might be arguing, why can't we have like 3 carbon atoms. We are going to leave 3 carbon atoms, and we are going to have, so let's take bromine atom is here, and we are going to leave this one, and this one. We are going to have the bromine atom here. So someone might argue it's not 1, 2, 3, 4, 5. You can say it 1, 5 dibromobenzene. No, the reason is we have to give them the least number. So rather than going numbering this direction, I can number it from here: 1, 2, and 3. It's 1, 3 dibromobenzene. 1, 3 dibromobenzene we already have here. So that means this is not an isomer. So we have 3 isomers now. This is an isomer, but it's same as this one. That's why we just remove it. So we can have 3 isomer structure from this. So therefore answer for question number 11 is B. So question number 11, our answer is B. Right. Let's go for next one. Question number 12. If you go for question number 12, they are saying that what are the intermolecular forces in triethylamine? When you hear the word amine, you think they have intermolecular hydrogen bonds. But the best thing is, let's draw this trimethylamine. Nitrogen can have 3 bonds. Okay, I'm just drawing 3 bonds. And it's a group 5 element, so therefore it has a lone pair of electrons. So there's a ethyl group, triethyl. So we have CH2 and CH3. That's an ethyl group. CH2, CH3 is an ethyl group. That's why they call it C2H5. So they say triethyl. So each nitrogen, each bond has an ethyl group attached to it. So we have another ethyl group, and we have another ethyl group. According to your syllabus, right? According to your syllabus, to have a hydrogen bond, these are the requirements you have to have. You have to have the 3 most electronegative atoms in the periodic table. It's called NOF. NOF means nitrogen, oxygen, and fluorine. And these 3 atoms should directly attach to a hydrogen atom. Then only you can get that extreme dipole, because when the highest electronegative atoms attach to the hydrogen atom, they pull the electron cloud of this hydrogen very strongly towards them. So as a result of that, this hydrogen will become extremely plus delta. The electronegative atom, nitrogen, oxygen, or fluorine, will become extremely minus delta. The attraction between this extreme plus delta with another molecule, another same molecule of minus delta, that's what we call hydrogen bond. For an example, if I take this HF molecule, and if I have another HF molecule here, so now this hydrogen has again extreme plus delta, and this is extreme minus delta. This plus delta and minus delta attraction, they are the extreme version of plus and minus. This is what we call intermolecular hydrogen bond. To have intermolecular hydrogen bond, we need NH, OH, and HF bond. We don't have that NH bond here. So therefore, this molecule cannot form intermolecular hydrogen bonds. So we'll remove the answers with hydrogen bonds. So that means I will end up with C or D answers. Now I have 2 answers, either C or D. C says London forces. Yes, obviously any molecule with electron cloud, they can form London forces, because London force means it's an instantaneous induced dipole. For an example, I'll take bromine molecule. When 2 bromine atoms sharing electrons, just sharing electron exactly in the middle, and their electron density, electron cloud is symmetrical. Why? Both are bromine atoms, so they are pulling power of electrons towards each self, or we call it electronegativity. It's same, but there can be sudden instability. Sometimes 2 electrons come close to each other. When they come close to each other, they repel each other. When they repel each other, even though electron cloud is supposed to be very symmetrical, one point it can have sudden instability. We call it instantaneously induced. Suddenly it appeared. So because of this instantaneous induced scenario, one side of the electron cloud will become plus delta, other side of the electron cloud will become minus delta. They are very weak plus and minus delta. So if another bromine molecule have this same scenario, plus delta and minus delta, this very weak minus delta and plus delta attraction between molecules. That's what we call London dispersion forces. So any molecule which has electron can have this sudden instabilities, instantaneous induced dipole scenario. As a result of that, they can have London dispersion forces. Okay, so I have two answers to London dispersion forces. But in answer D, they talk about permanent dipole-dipole interaction. Yes, it is possible, because in this one, nitrogen and carbon and nitrogen have bonds, and nitrogen is more electronegative than carbon. So obviously this nitrogen atom will be having minus delta charge, and they are permanent, because reason is nitrogen is more electronegative than carbon. As a result of that, this has a permanent dipole. If you take another trimethylamine and the nitrogen is minus delta and the carbon atoms have plus delta. So when this plus delta carbon atom, so here also you have C2H5, here also you have C2H5. Then this plus delta carbon atom get attracted to this minus delta nitrogen. We call it is a permanent dipole-dipole interaction. So therefore in this trimethylamine you can have London forces as well as permanent dipole-dipole interactions. Therefore question number 12, my answer is D. Right. Let's move forward. Question number 13. Okay, they are saying that the diagram shows the repeat unit of polypeptide made from only one amino acid. They are talking about one amino acid. They are talking about amino acid. Let's remind what is the structure of the amino acid. When you take an amino acid, there's a carbon atom, central carbon atom, there's a hydrogen atom, and there's a R group. One side there's a COOH group, and other side there'll be a NH2 group. That's the basic structure of the amino acid. They say that they hydrolyzed this polypeptide. Hydrolysis means actually they break the polymer and bring the amino acid back. Okay, now let's break this polymer. Let's bring our amino acid back. I'm going to use this structure from the top to use it as my base. Okay, let's take carbon is there. Okay, this carbon atom is fine. Yes, hydrogen atom is there. Okay, there's a hydrogen atom. There's R group. I think this is the R group. Okay, this whole thing is the R group. So what is the R group? We have carbon with 2 hydrogen, then carbon oxygen double bond, OH group, done. Then they will bring the amino acid back. So I think this is the COOH part, and this is the NH2 part. So they will come back, because the water molecule, now we can see in the polymer structure there's a carbon oxygen double bond. From the water molecule you can take the OH group. Alright, so you get COOH, and we can see in this structure there's a NH group. From the water molecule we get OH and hydrogen. H2O means 1 hydrogen and 1 OH group, isn't it? So OH is here, so hydrogen should be given to this nitrogen, so it will become NH. Okay, now you get NH2 group. Okay, now we got the amino acid. But they are saying that this hydrolysis is done in some medium. What is that? By using excess aqueous alkali. That means the medium of this reaction is an alkali medium. Alkali medium, there's a base. When there's a base like sodium hydroxide or anything, let's assume base means it has OH minus ions. Basic medium compound react with acid. Where do we have acids? COOH group is a carboxylic acid group. Here also COOH group, carboxylic acid group. What will happen? They will lose their hydrogen atom as H plus ion. So this hydrogen atom will move out as H plus ion to combine with this OH minus ion to form a water molecule. This will become minus then. Here also this bond will also break. This hydrogen will go out as H plus, and this will become O minus. So this H plus combined with this OH minus ion forming water. So that means in my product I can't have C double OH group. Instead of that I have to have C double O minus groups. This part is clear, but nothing happens to NH2 group because the medium is alkaline. NH2 group is also alkaline. So therefore it can't change its structure. So it can't have any change in the NH2 group. So this is wrong because there's a change in the NH2 group. So my answer is B, C and D. In B, both COO minus group, COH group becomes COO minus. That seems fine. But here one COH group remains as it is. That's not possible because basic medium can't decide which COH group they are going to react with. So if there's two COH group, it should react with both of them. Here nothing has happened to the COH group. That's also not kind of be our answer. So therefore answer for question number 13 is B. That's our answer. Right. Now let's go for next one. Question number 14. Which structure of amino acid lysine is a sweeter ion? Okay, to have the amino acid, we know that there is a basic structure: carbon atom, hydrogen, COH group and NH2 group. Carbon atom, hydrogen, COH and NH2 group. Carbon atom, hydrogen, COH and NH2 group. Carbon atom, hydrogen, COH and NH2 group. Then what is this sweet ion? I'll just explain. Okay, let's take this is our amino acid. So we have carbon atom, R group, COH group and NH2 group. Can you see that in an amino acid we have a basic group? This is alkaline group. And this is an acid. So we have the acid and base both in the same molecule. So when the acid and base part in the same molecule, there can be acid-base reaction. What is the acid-base reaction? Acid will give proton to the basic group. So what will happen? H plus ion will be transferred from the acid group, making it, so it will become CH, COO minus, and now that H plus ion is here, so this NH2 group will get another H plus ion from the acid part. So it's a H plus ion, so therefore this plus charge is there on the nitrogen atom now because of H plus ion came there, and other groups will remain as it is. So there's a R group here. So that's what we are seeing here, looking here. Okay, so there's a COO group. Okay, H plus ion is given, but not here in this NH2. It has given to another NH2. But there's nothing wrong here, but that's not the thing that we have learned, right? So we'll keep it as a question mark. Here nothing has happened. COOH group did not give its H plus ion. It cannot have, because we have only one COOH group in this molecule. It's incorrect. COOH has to give the H plus ion to form the sweet ion. Nothing has happened to the COOH. No, it's not our answer. Here COOH has given the H plus ion, but where is that H plus ion? You can't find it anywhere. So we know that B, C, D cannot be our answer because it's violate the basics that we have learned. A is a doubt because it doesn't show what we have learned. We thought that it goes to the other NH2 group, but it has gone to NH2 group. So if you take the basics of the chemistry, basic principle of the chemistry, A doesn't make anything that makes it where we can't accept it. We can accept it. The only thing is that's not the thing we have learned. So in MCQ question, they ask you to select the most suitable answer. B definitely cannot be our answer. C definitely cannot be our answer. D definitely cannot be our answer. Therefore our answer is A, because with the basic principles of chemistry, it gives us an acceptable answer. Right. So we discussed the next 5 MCQs. So tomorrow I'm going to release the last 5 MCQs of this paper. We were just talking about the exercises for you to do at home for neurogenesis. So there are 4 more. I'm going to add it today. So one thing is imaginative play with children entering their will. So if you take 5 or 6 here in your home, so that's the best place person to play with. The reason is their games are mainly based on imagination. So if you are going to play with them, always get into their level, play with their imagination. They talk about dragons, dinosaurs and everything. So when you play with them in their level, your brain imagination will improve. That will stimulate creative neural pathways. The next one, intentional networking. So what you can do is you can attend networking events. There are plenty of networking events everywhere around the world. And then what you're going to do is make sure you will at least meet 10 new people and you will have a meaningful discussion. You are going to have a discussion based on the topic that networking event is based on. If the topic is based on law, you have to learn about the law and you have to talk about it. If it is based on engineering, you have to learn before going in advance, learn about that engineering basic concept and try to build a conversation with them. Random act of kindness. You can do this one. It can be, it doesn't need to be like big thing. Even just opening a door for a person, that's also a random act of kindness. So when you walk on the road or anywhere where you can find, try to help people. So this will boost your emotional intelligence. The last one is generational wisdom. The next thing what you can do is find a senior citizen, and what you're going to do is actively listen their life experiences, because from those life experiences you will be able to learn and awake a new path, new ways of see the life around you. Okay, we'll finish the third part of our section. So if you have any doubts in any theory part, just leave a comment below, then I'll explain in a separate topic, and hope to see you soon with the last part of Unit 5 paper. Thank you.